So work out the height of a smaller bottle. So they want us to work out the height of this guy. So all the way. Anyway, so let's just call it h. So before you work out the height of this water bottle, we can start by looking at things that will help us. So we need the ratio of the lengths to find the height, and we can find that ratio of lengths from the ratio of the volumes. So let's start with the ratio of the volumes. So the ratio of the volumes will be equal to 500 over 2000. That will be equal to 0.25. So which means that the ratio of the lengths, like I said before, when you work backwards from volume to length, you find the cube root. So cube root of 0.25, and that will be equal to 0.63, which means that the lengths of the smaller bottle are equal to 0.63 multiplied by the length of the large bottle. So H basically will be equal to 0.63 multiplied by 32, and that will be equal to 20.2 centimeters, because that's length. Good. Number 9, here we have two mathematically similar cups, and we're given this length. We are required to find D. So another approach, if you're given lengths, is just to find the ratios of the corresponding lengths. So D over 9 should be equal to 8 over 12, which implies that D will be equal to 8 multiplied by 9 over 12. Then you just plug that in the calculator to get 6 centimeters. And then the second part of this question, so we are told that the volume of B is 160. So the volume here is 160. Work out the volume of A. So what we need to find here is basically the ratio of the lengths, and I'll basically work out the bigger shape divided by the smaller shape, because I'm trying to find the volume of the bigger shape. So I want to know how many times the bigger shape is as compared to the smaller shape. So the ratio of the lengths, so ratio of the lengths will be equal to 12 over 8, and that will be equal to 1.5. So that's basically, that means that the lengths of the bigger shape are equal to 1.5 times the length of the smaller shape. So, but what I'm interested here is the volumes. So the ratio of the volumes will be equal to 1.5 cubed, which is 3.375. And that implies that the volume of A is equal to 3.375 times the volume of B. It's bigger, 3.375 times the volume of B. So volume of A will be equal to 3.375 multiplied by 160, and that will be equal to 540 centimeter cube. And that's basically how you solve that problem. So now let's look at part C of this question. So in part C, we have two solids, P and Q. We don't know the solid, so let's just sketch. Let's just say this is P, this is Q, P, Q. And basically, these are similar. I'm not saying that they are rectangles or, squares. No, they're just solids and two solid plates. This is just meant to help you visualize what's going on. So the surface area of P uh, is P, and the surface area of Q is Q. Yeah. So this is centimeter squared and centimeter squared. All right. So the weight of P is W. So here, W grams. Okay. So that's the weight of P. Find an expression for the weight of Q. Give your answer in terms of P, Q, and W. So one thing that you have to remember is that the weight affects volume. So when the weight of a substance increases, its volume also increases. So note that when the weight of a substance increases, its volume also increases. So, which means that when we'll be working through this problem, we shall be considering the weight to represent the volume, because when the weight of the substance increases, its volume increases. The weight affects the volume. Okay, so we will need the volume scale factor and the ratio of the volumes when calculating that. So first of all, you're given the area. So let's start from the ratio of the areas, and then we'll find the ratio of the lengths, then we'll find the ratio of the volumes, and then we'll use the weight to find the volume of um, the weight of Q. All right, so the ratio of the areas will be equal to, now because I'm trying to find the volume of Q, I'll, I'll write my ratio of areas so that um, I can be able to know how many times Q is bigger than P, right? Or how many times the volume of Q is bigger than P. So that's the comparison that I'm working with. So basically the ratio of the areas will be equal to Q over P. Um, so basically the area of Q is Q over P times um, the area of P. All right, so from there we can go ahead and find the ratio of the lengths. So the ratio of the lengths will be equal to, now when you find the ratio of the lengths from the ratio of the areas, you find the square root, because when you find the ratio of the areas from lengths is square, so the opposite of squaring is square root. So Q over P, and then the ratio of the volumes will be equal to the square root. Now, if we have the ratio of the lengths, to find the ratio of the volume, you square that. So Q over P squared. So which means, this means that the volume of Q is this much times the volume of P. So basically to find uh, uh, the weight, which represents volume in this case, so the weight of Q will be equal to W, which is the weight of P, multiplied by the ratio of the volumes. So that will be equal to square root of Q over P squared. And that's basically um, the weight of Q in terms of PQ and W. Uh, Sorry, I think I made a mistake. So the ratio of the volumes from here, you need to find the cube of that, because to find the ratio of the volumes from the ratio of lengths, you cube. So basically this will be cubed.